Over the years on my channel, I've tested many portable power stations up to 3,000 watts. Today I'll be testing out this Opus 3600 watt lithium iron phosphate portable power station with a 3072 watt-hour battery. Lithium iron phosphate portable power stations of this size are typically in the $2,500 to $3,000 price range. This unit is well under $2,000. If this higher capacity Opus power station performs just as well as the lower capacity Opus power station that I've tested in the past, then it would definitely be a great buy for the power output. This power station was sent to me by the manufacturer, but as always, you can expect a fair and honest review. Opus power stations have high customer satisfaction ratings. Okay, let's get the review and testing started. When you purchase this power station, also included is this owner's manual, written very well, a warranty card. The warranty for this portable power station is 3 years. Charging cable for your AC receptacle. A good quality MC4 to Anderson cable for solar charging. A 3-foot or 1 meter Anderson to Anderson cable. For charging this power station in your vehicle, also included is Anderson to DC accessory socket. And last is this cable that goes from Anderson to 7909 connector. The weight of this power station is 83 pounds or 37.8 kilograms. You have a maximum output of 3,600 watts with a 7,000 watt surge. So you have up to 30 amps at 120 volts from this section outlined in white. Right over here you can see there's an RV connector. You can have the full output for this power station on this one connector alone. If you want to use the full output for the power station using standard receptacles like you see here, you're going to have to spread out the load. Each one of these is rated up to 20 amps. Maximum AC input charging for this power station is 1,800 watts. Using solar, you have a maximum input of 2,100 watts. This portable power station uses a 51.2 volt lithium iron phosphate battery with a 3,072 watt-hour capacity. Using an app, which I'll show you later in this video, you can control this power station. Because of the size of this portable power station, there are 2 ways that you can carry or transport it. One is using the handles, one person on each side carrying the unit, or you can carry it yourself. You can see at the bottom of the unit, you have these very smooth wheels, one here and one on the back side. At this end of the unit is a handle that you will slide out, easily rolling the power station, and then you can position it upright and push the handle down. According to the manufacturer, when the battery inside this unit is fully drained, you can expect approximately 1.7 hours to fully charge it using an AC receptacle. I'll let you know later in this video after performing tests if that's true. To power up this unit, you simply push and hold the power button a few seconds. As you can see right over here, 52%, there are segments illuminated in blue. If it was a higher percentage charge, you would have additional segments illuminated. As you're discharging the battery, you're going to see the segments disappear. You can turn the display on and off to conserve the battery. Just a quick press of the power button. Push it again to turn it on. You have 2 DC sections on this unit, a USB section along with a 12 volt 30 amp output. We're going to be testing this by loading it up with a bunch of different devices and load testers, and then also checking to make sure we can get 30 amps from this Anderson connector. We're going to test the 12 volt 10 amp section here. The DC jacks and the accessory socket are all on the same output, so I'm only going to be testing the accessory socket to make sure that we can have a 10 amp output for at least 30 minutes. For the AC section, I'm going to hook up an oscilloscope. We're going to take a look at the waveform, make sure it's pure sine wave. We're going to take a look at the frequency. This unit has the ability to switch between 50 Hertz and 60 Hertz, so we're going to verify that that works. And then we're also going to take this outside and do testing to see how well it handles high inrush loads. We're going to try overloading it to make sure the protection kicks in to turn the power off to these receptacles. And we're also going to place a load just below the 3600 watt maximum when this is fully charged to make sure that it can run continuously without the system powering off and showing any error codes. So before I get started with any of the testing, first let me show you what the unit looks like all the way around, and then we're going to take a closer look at the display. I'm going to show you how to change the settings on the frequency as well as the charging rate. You can charge either 800 or 900 watts on a low setting, or you can charge at almost 1800 watts using the high setting. Looking at the left side of the power station, you can see there are two thick rubber feet. When the unit is stood up, it will be resting on the wheels and those two rubber pads. You have two cooling fans on this end with ventilation openings to allow for very good cooling for the unit under load or charging. Behind this cover, reach your nail in here. They probably could have made this a little easier to open. It's rubbery, so you can bend it. You have where the AC power cord plugs in to charge the unit using AC mains. Your solar charging is going to be done right here by the Anderson connector, as well as your vehicle charging. And down here you have two circuit breakers. One protects the input and the other one protects the output. So you want to make sure both of these are on before using the unit. Down here is another connector, and this one is used in the event that you purchase an optional battery to be used with this power station to extend your runtime. You would plug the connector right into here and go up with the cable and place the battery on top of the unit. Looking at the right side of the power station, not much there, just some ventilation openings and the handle that slides out at the bottom of the power station. In the vertical position with the handle extended, you can see the bottom of the power station. There are four large rubber feet bolted into the power station. And right here is a look at the rear side of the power station. Now the one thing I like to see on power stations, especially the larger ones, is an LED area light. So if you're working in a dark area, you'll be able to see exactly what's going on in that dark area by having the light on the power station. So maybe in the future, it's an inexpensive thing that they can add on to the back panel of the power station. Now that you've seen the entire power station, now let's go over some settings. So if I push DC here, you're going to see over here it says USB Type A, Type C is now active, hours remaining with the state of charge of the battery. And over here is going to be your output power, which is 4 zeros. Same setup here. The only difference here is car and DC. And AC, you just heard the relay click, turned on the output, 4 zeros for the output wattage, 26 hours remaining. Over here, 60 hertz, and it's giving you the output voltage of 119 volts. Okay, so let's turn this off. To adjust the AC input charging speed, what you have to do is push the DC button and the IOT at the exact same time. Right here you can see L for low, it says set. Push the IOT button. Now it's on high charging. Press power. Now it says SUC for successful. Push it again. And now you're back to normal. To adjust the output frequency for the AC receptacles between 50 Hz and 60 Hz, what you're going to do is make sure the AC section is off. So now we're on. Make sure it's off. And then you want to push the DC button and the power button at exactly the same time and hold it. Okay, 60 Hertz. You want to change it? 50 Hertz. The switching will be done from there. When I perform the testing on the receptacles, we'll make sure that it switches. Now I'm going to push set, hold for 3 seconds. You didn't see anything say successful because the setting was the same that it was previously set. This button over here turns on and off the Bluetooth and Wi-Fi connection. This unit can be connected to the app using either one. If you're going to connect to it using Wi-Fi, you do need to use the 2.4 gigahertz setting. So if you have a dual band router, that should not be an issue. If you're not going to be using this portable power station for a prolonged period of time, the manufacturer suggests or recommends that you always store it in a horizontal position and keep it around 60%. Every 3 months, you're going to want to drain the battery all the way down towards 0, charge it back up to 100, drain it to 60, and then store the power station. By doing that, you'll ensure maximum battery life for the power station. Before I connect up the load tester to get the testing going on this output first, and then this one, first let me show you how to connect up the app. To install the app on your phone, you're going to go to page 2, scan right here, select the proper app. Once you install the app on your phone, you're going to make sure Bluetooth is activated. You're going to push the IoT button on the power station, and you're going to see both symbols flashing. When you connect to either one, it's going to go solid. Once you're logged into the app, the next thing you're going to do is make sure that you allow location and also allow the app to scan Bluetooth. Once you're logged into the app, you're going to see the page right here. It says Add Device. So I'm going to click Add Device. You're going to see this screen right here. You're going to tap in the circle. It says Confirm Device is in the pairing state. And then you're going to click Next. Going to select Energy Storage Battery Mega 3. Tap Next at the bottom. And here you can select if you'd like to use Wi-Fi, 2.4 gigahertz, not 5. In my case, I'm going to tap Use Bluetooth Direct Connection. With the device added, you can see it right here. Now I can tap on it, and it's going to connect to the power station. You can see on the left, that's the temperature of the power station. It says 2 days, 10 hours remaining at 51%. Input 0, output 0, solar charging 0. Not connected to a backup battery. And AC is at 0 at the bottom. At the upper right hand corner, the gear icon, you tap on that. Brings you to this screen. Rename, share device, temperature units, auto timeout, unit timeout, screen timeout, AC timeout, firmware updates, help center, specifications, and you can unlink the power station if you desire. You could select how long you want the AC output to run by tapping AC timeout, and you can select the setting that you desire right here. Tap on firmware, and here you can see the device ID, signal strength, firmware version. Hit the arrow to go all the way backwards. Keep tapping. Top left, it's going to bring you back to the same screen. Tap the person at the upper left corner, and it's going to bring you to this screen here. Third-party services available, Alexa, Google Assistant. You can select the language that you want, perform a network diagnosis, contact customer support, help center, and other things. So it's a very simple app to use. You go to the screen again, you see right here with the power station saying Energy Storage Battery Mega 3. Tap on that once. It's going to bring you back to this screen here showing the power station. Then you can click on Output, and you're going to see this screen here. You're going to notice over here there are power buttons that you can click to turn on your AC output, DC outputs, etc. Let's do AC. You just heard it click on. Click off. Let's try the DC. That's on. So everything does work just fine. Okay, let's go on to the testing. I have my electronic load tester connected off to the side, connected up to the DC output here at the accessory socket. The setting on the load tester is 9.9 amps, just a hair under the 10 amp rating. I'm going to turn it on, let it run for about a half an hour, just to make sure there's no issues supplying that much power out of this section. Okay, the electronic load tester is connected to this DC section right here. I want to make sure it can handle up to 10 amps. So I have the load tester set at 9.9 amps. I'm going to turn it on, wait a half an hour, make sure this has the ability to supply that much current. Here we go. Over here we're drawing 125 watts. Okay, not a problem at all. It ran for 30 minutes, and you could hear the cooling fan on the power station is much faster. So this output can definitely supply up to 10 amps. Okay, now on to the testing for the 12 volt 30 amp output in the USB section. I sacrificed this cable because I have another one. I cut off the end, added ring connectors to connect to the electronic load tester. The electronic load tester is set at 29.2 amps, so just a little bit under the 30. I'm going to turn it on. We'll wait about a half an hour, make sure there's no issues. You'll see the wattage right over here. So 12 times 30 is 360. It should be just a little bit under. 344. Okay, total success. Worked out perfectly. Temperature of the cable, I'd say it's warm to very warm, and you can see the temperature here using thermal imaging, 113.6 Fahrenheit. With this successful and that successful, now I'm going to test the USB Type-Cs. Now I only have one of these modules that can test up to 100 watts. So I'm going to set this one right around 92 watts. And at the same time, while this one is discharging, I'm going to have another one connected here at 62 watts. I'm going to leave both connected for about a half an hour. If there's no issues, then you're going to know that the 92 will also work on the opposite side, because if this port can handle it, this one can also handle it. It's designed to have 100 and 100. 156 watts between both. You can see this one here is 91.6, and if I switch channels, that one is 62.3. Okay, a half an hour, no issue at all. 91.5 on average from this port and 62.5 on this one. Let's turn this off. Now I'm going to place loads on the Type A ports. 4 loads connected to the Type A ports. This one here is going to apply 2 amps to that port. This one here goes to this load tester at 3.08 amps. This wire here goes to this small camera, and then the last one goes over to my smartphone. I'm going to leave this connected for about 30 minutes, come back, just to make sure there's no issues with the Type A. Okay, not a problem, and it's been going for about a half an hour. Let's disconnect all this and go on to the next test. Now let's take a look at the AC output, the waveform, and frequency. Turn this on. I did check the voltage over here against my multimeter, and it's very close, within a half of a volt. It says 119 volts, 60 hertz. You can see the waveform is pure sine wave, 60.0000 hertz. Now I'm going to place a heavy load on the output to see if it has any effect on the waveform. Okay, so all is good there. Now let me switch over to 50 hertz. Turn this off first. And guys, right on the money, 50.0000 hertz. Now I'm going to show you what you can expect when you charge this unit using AC mains set to low and high. So right now it's on high. What I'm going to do is when I charge this up to 100% for the constant power output test, I'm going to use the high power setting to make sure there's no issues with heating when charging the unit. Let me unplug this. Now let's switch to low. Keep in mind you can charge this unit while you're discharging using the AC mains. If it's a heavy load, you're going to have less charging input because a lot of that current from AC mains is going to be flowing into the load that's being used. And this is what you can expect using the low setting, around 950 watts. Let me disconnect this, and I'm going to show you now what you can expect when you charge this from your vehicle with the battery not being charged and with the engine running. So you can see right around 12.67 volts. We're getting around 7.6 amps. Over here it's showing 90 watts. Now we're going to bring this to 14 volts to see what kind of an effect it has on the output wattage. That's going to simulate the engine running, charging the battery. So you gained another 21 watts. So if you have this in your vehicle with the engine running, 14 volts, you can expect right around 110 watts going into the battery of the Opus power station. There's one more thing I want to show you before we take this outside to get the AC output testing, which everyone wants to see, and that's to show you the UPS feature. Just like other power stations, this power station has an uninterruptible power supply feature. So whatever you plug into this bank of receptacles, what's going to happen if you have this plugged into the AC mains as well, power is going to be flowing from the AC mains through the system, out the receptacles, into your load. In the event of a power failure, we'll pull this out to simulate it. What's going to happen, it's very quickly going to switch from AC mains power to the inverter built inside this unit. There's going to be a very brief switching period, 20 milliseconds or less. And just so you can hear it, I'm going to have this hair dryer on high heat on a low setting. Going to plug in the power station, let the power flow through into the hair dryer, and then after about a minute, I'm going to disconnect the power to simulate a power failure, and you're going to hear that very fast switch over on the AC output. And you heard that very fast changeover. And if you noticed, the 1750 watts on the high charging setting, 400 of those watts was going to power this on low heat, and the remaining 1400 was going to charge the battery. So this definitely does switch between AC mains and the inverter in the event of a power failure. Before I take this outside, I'm going to bring this up a little bit higher from 39% up to 50 or 60%. I'll plug in this cord, let it charge for a while, and then we're going to get the AC output testing going. What I've noticed over the years is if the power station has no problem starting up this circular saw, it will have no problem at all starting up a refrigerator or even running a microwave oven. The circular saw has very high inrush current. So let's turn on the AC output. We got the output voltage here. It's set for 60 Hertz. Let's see if it starts it up with ease. I have to say that started up the easiest out of any of the power stations that I've tested. Okay, now what I'd like to do is add another high inrush load to be used with the rigid saw. No problem at all. So now let's do this one and then add this one in. Outstanding. Now let me add in a shop vac with the saw with the compressor. incredible. And there you have it, overload protection, ERA 001. So that does work. You're going to notice the voltage is going to drop for about 15 seconds maybe before the overload protection kicks in. But the good thing is, it does work. Okay, what I'm going to do now is take the power station, charge it up to 100%, let it sit for about a half an hour to cool off. Then I'm going to connect a 3,450 watt load, just a little below the 3600 maximum, to see if the power station can handle that load continuously until the battery inside this unit is fully drained. You can see the furnace, toaster oven, fan, hair dryer, and soldering iron. I'm going to plug all those in, start the timer, and hopefully the system can maintain that power output until the battery is fully depleted. Let's get it going. Okay, total success, 44 minutes and 18 seconds. Power station never turned off, and it was able to maintain that 3,450 watt load throughout the discharge cycle. While it's at the low state of charge, I want to take a look at the accessory socket to see what the voltage is, to see if it's more or less regulated. I'm tapped into this 75 watt light. You can see the voltage over here, 12.8 no load, under load, 12.5, and that's 75 watts. So excellent regulated output for the DC receptacle at a low state of charge. See if I can charge this only 10 minutes after the test. And as you can see, yes, you can charge it. You don't have to wait. The cooling system on this unit is very good. According to the manufacturer, this power station should be able to handle up to 2,100 watts from the solar panels. I only have 3 400s, so we're going to be testing at 1,200 watts. The sky is a little bit hazy, so I'm expecting the 1,200 to come in just a little bit lower. Let's take a look. And right here you can see it charging at 1,150 watts. I'm going to leave it charging for about a half an hour just to make sure there's no issues charging this power station. And guys, that is it for the testing on this Opus power station. As you saw, it performed extremely well. I hope you enjoyed this video.